Alright, for section 7.2, we need to solve linear systems by substitution. And yesterday we talked about how to graph a system of equations and figure out the solution by looking at the graph where the two lines intersect. And today we're going to figure out a new technique. It's going to be a technique called substitution. And we're going to sort of look at how this works for us. Okay, so let's say we have this system here. We have x equals negative 2y plus 2. I'm going to call that equation number 1. And 3x plus y equals 16. I'm going to call that equation number 2. Well, it looks like in equation number 1, x and this x, these are the same x, okay? But it's also telling me that x is equal to a negative 2y plus 2. So the cool thing is that now since these two x's are the same, and I know x is equal to negative 2y plus 2, I can actually substitute into equation 2 for x. And here's what I would get. I would get 3 times negative 2y plus 2 plus y is equal to 16. Make that blue. So the great thing about this new equation here is that I have created an equation and they only have y's in it. Whereas in equation number 1 I have an x and a y, and in equation number 2 I have an x and a y. There's no way I can isolate those and solve for it, but in this equation I do, and I can solve this thing for y. That's the substitution process. So we're going to distribute now. That's going to give me negative 6y, and then plus 6 plus 4, plus y, sorry, plus y is equal to 16. And I can combine like terms and say negative 6y plus y is a negative 5y, plus 6 is equal to 16. I'll subtract 6 from both sides, and move the screen down. I can see that negative 5y is now equal to 10. I can divide by a negative 5, and I can see that y is equal to negative 2. Alright, great. That's part of the answer. Remember, the answer to a system of equations is a coordinate point, x comma y. So I've just figured out now through substitution that the y is negative 2. But I don't have the x part, x and y. So what I need to do is I can take my answer for y and I can resubstitute it right back into the original one or any of these equations and solve for x. So it says over here now that x has to be negative 2 times a negative 2 plus 2. So x has to be positive 4 plus 2. So x has to be 6. So it looks like the answer to my system is 6 comma negative 2. So if I was to graph x equals negative 2y plus 2 and graph 3x plus y equals 16 simultaneously on the same coordinate plane, I would expect that these lines would intersect at the point 6 comma negative 2. So here's what I can do. I can go to fluid math and I can see that I have x equals negative 2y plus 3x plus y equals, and you can see right here at 6 comma negative 2 is the one spot that they do share in common. So that means that my solution to the system is indeed 6 comma negative 2. And that's the whole idea about substitution. Let's try another one together. Alright, I got 4x minus 2y is equal to 14. That's equation number 1. And equation number 2 says 2x plus y is equal to negative 3. Well, I can see that in equation number 2, I can easily solve this for y. So I can say y is equal to negative 2x minus 3. So if y is equal to negative 2x minus 3, I'm going to substitute it right back into the first equation right there. So I'd end up with this. 4x minus 2 times, I have a negative 2x minus 3, has to equal 14. We're going to use the distributive property here. And we're going to get 4x plus 4x plus 6 has to equal 14. 4x and 4x is 8x. So 8x plus 6 has to be 14. We're going to subtract 6 from both sides. And I get 8x is equal to 8. So I'm going to divide by 8, isolate my x. Looks like x is equal to 1. Great. Now remember, the answer, of course, is always going to be a coordinate plane, x comma y. I've figured out that x has to be 1. So I'm only halfway done. So to solve back for y, I can resubstitute the x right here and get y. And I would see that y is equal to negative 2 times 1 minus 3. So y would be negative 2 take away 3. So y has to be negative 5. So the solution to this system of linear equations has to be 1, negative 5. So if I was going to graph those, here are my two lines that I've graphed. 4x minus 2y equals 14 and 2x plus y equals negative 3. I can see that they meet at 1, negative 5, which is exactly the same solution that I figured out over here through substitution. Okay, let's try one more together, and then we'll talk about the process. So it'll be a you try in class. So go ahead and pause. Alright, so let's see how you did. I can see from this first equation here, I can easily solve this for y. Y has to be negative x plus 5 if I subtract x from both sides. So if y is negative x plus 5, I'm going to substitute all this information for the y in the second equation right down here. I'm going to have this. I'm going to have 7x minus 9 times something equals 3. And I substitute in the negative x plus 5. Negative x plus 5. And I've created an equation that only has x's in it. So I can see I'll have 7x. I'll distribute here. Negative 9 times the negative x is a positive 9x. Distribute negative 9 times 5 is a negative 45 is equal to 3. 7x and 9x is 16x. And minus 45 is equal to 3. So we'd add 45 to both sides. We'll add 45 to both sides. And we get 16x is now equal to 48. We'll divide both sides by 16. Cancel them out. And x would have to be 4. Alright, so now that x is equal to 4, I can substitute these back in. This isn't right, it's not 4. I'm going to think about it. Let's go back here. This should be 3, sorry. Yikes. Okay, 48 divided by 16, 3. So now that I got my x is equal to 3, I can substitute my x right back into there, and I would see that y would have to be negative 3 plus 5. So y would have to give me, looks like 2. Great. So the solution to my system here, the solution would have to be the coordinate point 3, 2. That's my x, and that is my y. So let's go ahead and see if we got those right. So the first one was x plus y is equal to 5. And the second one was 7x minus 9y equals 3. So I do 7x minus 9y is equal to 3. So if I did this correctly and didn't make any algebra mistakes or addition subtraction mistakes, when we graph these two lines on the coordinate plane, they should meet somewhere. And where they meet is my solution to my system. And it looks like these are meeting at the point 3, 2. If I just zoom in a little bit more, yep, there we go. 3, 2, which is exactly the same point that I came up with over here. And that is solving systems by substitution.